Hi, this is Andrea Hendricks, and let's talk about the calculator and how to use it solving radical equations and inequalities. Really, skills that you've seen before, just applying to a different type of function. So here, if I want to solve the equation, the square root of x is equal to x minus 2. Now, remember we did this in the lecture video, and we did it by hand, so I know the solution is 4, but just to show you how you can verify all of this on the calculator. So one way is we can use the intersection of graphs. To do the intersection of graphs, I'm going to enter y1 and y2, and then find out where those two things are equal. So here I have y1 is the square root of x, y2 is x minus 2, and I graph them. This is in the standard viewing window, and then I use the intersect command. So remember that second trace 5 will give me intersect, and I have to enter first curve, second curve, and guess, which means move to the point of intersection, and I find 4, 2. So that would tell me my solution set is 4. Okay. Now another way to do it is the x-intercept method. To do the x-intercept, I have to do y1 minus y2, and that's equal to 0. So I enter the square root of x minus, be sure to put in parentheses, the second function x minus 2, or you can go ahead and distribute that negative throughout, and then graph, and then this time I'm using the 0 function, which is second trace 2. And to do that, I have to enter a left bound somewhere on the left, and then a right bound, and then guess. And I see the solution is the same no matter which method I choose. Now I've also included the inequality on this page because honestly, if you know how to do either of these methods to solve the inequality, it's just a different way to read the graph. If I wanted to find whether the square root of x is less than or equal to x minus 2, for instance, I can use my intersection of graphs to solve that. The square root of x is this radical equation. Where is that piece less than the line? Well, that happens to be from 4 to infinity, right to the right of the point of intersection. Now, if I wanted to use the other form to solve this, and I would need to think about where is the square root of x minus 2 less than or equal to 0. So here I'm trying to read the graph to find out when it's below the x-axis, which is still to the right of 4. So either method would allow me to get to the solution that I need. Now the other problem, the square root of 2x minus 5 minus 2 equals the square root of x minus 2. We know from solving that by hand the solution is 27. So I knew that the standard window from negative 10 to 10 was not going to work. So I think I did this from negative 10 to 40 with a scale of 5. And from negative 10 to 10 I think is what I did in the y direction. Okay? So from negative 10 to 40, if I graph this where I'm looking at y1 on the left and y2 on the right side of 0, using the intersection of graphs, I entered y1 and y2, graphed, then did second trace 5, first curve, second curve, guess, and I found my point of intersection to be at 27, 5, which the x value is my solution that I need. Now using the x-intercept method, I entered y1 minus y2, and I'm trying to find out where is that equal to 0. And so notice how I did that. The square root of 2x minus 5 minus 2 was my original function, and then I just subtracted off the square root of x minus 2. And then graphed it and used the 0 function, second trace 2, left bound, right bound, guess, and I found my 0 is 27. Now, how can I read those graphs to find out the solution to the inequality? So where is the square root of 2x minus 5 minus 2 greater than the square root of x minus 2, or where is it above that? Okay. So here is my y1, and here's my y2. So where is it above the graph? Well, that happens to be to the right of that point of intersection from 27 to infinity. Now if I happen to enter it in the form where I'm comparing it to 0, I'm trying to solve where that's greater than or equal to 0. I'm looking for where that's above the x-axis. Well, that happens also to the right of the 27. Okay? So either way, I would come up with the same solution. So just reiterating the facts that we talked about before with using the graphs to solve equations and inequalities. If you struggle with this, don't hesitate to contact me. Thank you.